Good afternoon, my name's Matt Harwood and today I'm going to be demonstrating how to clock the head of a vertical milling machine. Okay, so by the end of this session you will be able to describe how to clock the head of a vertical milling machine. Okay, I'm going to take you through the main parts of the machine. This is the head of the machine and this is the part that we're going to be aligning today. This is the table of the machine and this is where the work holding device would be mounted. And this is the knee of the machine that is responsible for holding the work table. Okay, first of all we're going to need a faceplate with parallel front and back faces. Next we have a dial test indicator. It's important that we select the plunger type. Here we have a clocking bar. We need a pair of parallels to sit the faceplate on. Next we have a 19mm combination spanner. We'll be using this to make the adjustments and loosen and tighten the bolts. Next we have the monkey. This will be sat on the clocking bar and it will hold the DTI, dial test indicator. Finally we have the Jacob's chuck and chuck key and we'll be using the chuck to hold the clocking bar. As with every engineering activity, safety is important and for this exercise we'll be ensuring that the machine is isolated. Personal protective equipment and clothing must be worn. That consists of safety boots, safety glasses and a boiler suit or overalls to protect your clothing. The reason we clock the head is to reduce the likelihood of this happening. Now we've set the equipment, we need to have a look at the current state of alignment. First of all, we've got to set the dial test indicator to 0. Next, we need to rotate 180 degrees and check the clock reading. You can see that the error is just less than 0.2 of a millimetre. There's clearly an error that we need to reduce or eliminate, and the first thing we need to undo are these 4 clamping bolts here. Now it's important when you've got 4 bolts that you undo diagonals. To eliminate the error, I've got to use the adjuster, which is situated here on this machine. First of all, we need to halve the error. We'll now see whether halving the error has done the trick. Success! Next, we need to tighten these bolts back up, and it's important again that we do it diagonally. Next we need to check the y-axis, so that involves setting the dial test indicator to 0, then rotating 180 degrees and noting the reading. As you can see in this direction the error is 0.4 of a millimetre, so that's quite a way out. These are the bolts that we need to undo to enable us to adjust this, and this is the adjuster. Because the pivot point's here, we're going to reduce the error by a lot less than half. So we're going to go for about 1/4 of the error. So eventually I've managed to clock the head in the y-axis, eventually, and now the DTI is reading 0 in 4 places, which is what we've been aiming for. Now we need to check that all the bolts are tight. We need to make a final check that we haven't disturbed something when we've tightened the bolts, which involves rotating the clock 360 degrees and watching the pointer to make sure it doesn't deviate from 0. And that's fine. And of course, the job isn't complete until we've removed all the equipment and put it away safely. So that's my next step. Hope you've enjoyed this presentation and more importantly, you've learned from it. Thank you.